So I want to start this one off by talking about what are the types of collisions that we're going to be looking at and dealing with. And the way we really categorize these there are three types of collisions. There's what we would consider a perfect elastic collision, which a really good example of this, though not perfect, is billiard balls. In real life, billiard balls aren't actually perfectly elastic, but we can kind of approximate them to be elastic. One of the billiard balls hits the other and almost takes all of the energy from it, right? And so in an ideal situation, perfectly elastic collision would be where momentum is conserved between the two objects and the kinetic energy is going to be conserved between the two objects. So both have to satisfy perfect elastic collisions. And then another key factor of this is they do not stay traveling together. They will go their separate directions. The second one we'll talk about and we'll look at is inelastic collisions. The example I suggested in the notes was like tennis balls. They have more of a bounce to them. You can think of these as they'll bounce off each other, but they compress a little bit on impact. So there's some momentum is conserved, but some energy can be lost. This can be through compression. Energy can be taken in the form of sound, heat, friction. All of this can happen from the impact. And then the last one we'll look at is perfectly inelastic collisions. Kind of not the greatest happy example, but a good example is car crashes. Cars crash and they tend to crumple into each other. Cars are actually built that way to absorb most of the energy on impact. So actually that's part of the physics behind how cars are built. But basically two or more objects would come together, they stick together, and then they continue to travel together. In the case of the cars, they would like skid together. They stick together after impact. Momentum is still being conserved. Energy loss is happening. Energy is not being conserved, just like the inelastic example, but there's actually more energy loss from this case.